down most of the day. Just I get these migraines that seem to manifest themselves in dizziness and vertigo. So that's what I have. Hi, Kylie. How are you? Good to see you. Let me do this over again. Oh, like I said, I'm doing better. I'm doing better. So, doing lots better than I thought that I was this weekend. So, good to see you guys. Much better today. So, hey guys, I've got a poll question for you. So, let me show you this. Let me go back here. All right, oh, where'd it go? All righty. My activities. Okay. Okay, so let me show you this. I'm going to share this with you guys. Polling. Okay. Hopefully this has got it for you. Let's see, 4, 7, yeah, 2, 3. Okay. All right, so what I want you guys to do, this is a hangman here. So start the hangman. Try and tell me what the answer. It says, what is the rate of motion called and how is it classified? So 2 words here. I'm going to give you a poll. When you get done, that'll be a poll question here. Start a poll. So answer to word wall. Okay, so this is a type response. Start a poll here. All right, so go ahead again. It's like regular hangman. So if I use Z, Y, X, don't use X, W, V. So I could die. so try the letter S. That works really good. There are 3 S's. So tell me what the name of this is. Hey, Carmen. Hey, Danny, good to see you. Dylan, good to see you as well. Grace, Cassidy, Madeline, Rihanna, and we have low numbers today. 11, 12 people. All right, so I told you, and then the letter E works really good. You got a lot of E's in here. So I'm going to use the letter U. Almost one left. Yep. What's the second word? Speed is a what? Oh, you can't write it in now. You already guessed. Thanks, Rachel. Anybody else? So the first word is speed. There you go, Chloe. Thank you. Anybody else? Dalton, DeAndre, Kylie. I got an I. Give you one more minute. DeAndre. M, you want me to try M? I'm dead. All right. Okay. Time's up, ladies and gentlemen. I did not get it, but I know what the joke is here. All right. Speed is what? Starts with S. Okay, so let me stop right here. Thanks for participating, ladies and gentlemen. All right, so let's go over to this one. All right, so we're going to do distance. We're going to do speed calculations. So I know many of you, because I looked at your iReady scores, are really struggling in math. Okay, but we have ways of helping you overcome those struggles. It is also a way to move forward because even though you may be struggling in math, iReady has a path for you so that you can improve your math scores, and that's what we want to try to do. Right? We want to try to improve your math scores, and this is the part of physical science. You may have had science classes in high school or middle school that had no math in them, so these do have some math. So, and they're pretty straightforward. Right? Pretty straightforward. So motion, again, is classified as how fast things are. Using speed and velocity, we can use math to value that. So we do that. Okay, you have your GPS, you have your phone. Your phone can tell you, how fast you're traveling if you run, right? Anybody a runner at all? Somebody that does running on a regular basis for exercise or jogging, anything like that? Anybody one of those people? If you were in high school, would you be on the track team? Okay, all right. And they used to time you, right? What did they use to time you? How did they know you were going fast, right? What did they do? What did they do, Danny? Did they use something like this? What's this? You guys see it? Yeah, stopwatch, right? So we need something to time something. Okay, so your car tells you how fast it's going because it measures how far you're going by the wheels. The wheels rotation tells you how far you went, and it also measures how fast your wheel is turning. So two things: the distance and how fast, using a stopwatch, right? So it's all internal, right? So that is how that's how we use this. We use to find speed. We need to time it, and we need to know how far away we went. Boy, I'm losing my voice here. How far away we went. All right, so let's take a look here. Speed versus velocity. Velocity calculations. We'll be doing speed calculations, and then we'll be talking about graphs and how to look at graphs, because that's really important in terms of a goal for everybody to become lifelong learners is to be able to read a graph, interpret it, right? So that's really important. So who else did we get in here? Aaliyah, how are you? John got in here. Jasmine, good to see you. Ken, good to see you. And Madeline, I think I said hello to Madeline. And Journey, good to see you as well. We're getting some people in here. Another person in here. Gabby, good to see you as well. Okay. Okay. So what we talked about with speed, in your own words, what would you say speed is? Right? In your own words, what is speed? You could, if you don't know, you can put IDK in there, just in the poll. We do have a poll. We have a giveaway, some points today for people that participated on Friday. How fast you are going, how fast something is moving, velocity. Okay, so speed and velocity are very similar, except for velocity uses direction. All right, how fast or slow something goes. Remember, what we need in order to do this, we need to have something to measure our time, and then we need to know a distance. Okay, so what is the fastest land animal? Can you guys know what that is? Fastest land animal. Probably do. Gets up to 70 miles an hour and then becomes breathless. It's not. It's so it better get their prey before They run out of steam. Yeah, there are 6 people said cheetah. Thanks, DeAndre, Danny, Dylan. Thanks, Dylan, Gabby, Kylie, Rachel, and Adriana. You guys are so much better than my first hour. I had like 4 people participating, and by the end of the hour, had nobody participating. So it was amazing. Cheetahs, for sure. So here we go, 70 miles an hour. Fastest car, 300 miles an hour if you want to buy a Bugatti, several $1,000,000. Usain Bolt reached 30 miles per hour. Pretty fast. You'd think that we're faster than that, but if you try to run, you're running a mile every 5 minutes. And I mean, I think my jog is like 15 minutes a mile. So this guy is 3 times faster than me. All right, so speed is the rate of change, how fast something is changing. And what we talk about is we talk about average speed and average and instantaneous speed. So average speed, if we look at average speed, we talk about, let me get this into a different color here. Average speed is what we do most of the time, because if you think about when we drive somewhere, we are slowing down, speeding up, stopping, right? So we don't want to have to take into consideration all those stops and starts and so forth. So we find the average speed by taking the total distance divided by the time it took, right? Instantaneous speed is when you look at your speedometer on your car. It may say 50 miles an hour. Well, that's the speed you're going right at this moment, but you may slow down. And 50 miles an hour tells you that in an hour, if you keep up that speed, you're going to be 50 miles down the road. So if you don't go for an hour, then you get some portion of that, 50 miles an hour. If you go a half an hour, you get 25 miles. If you go a tenth of an hour, you get 5 miles. Okay. But again, our average is when we take all our timing, right? Because it would be crazy. Oh, you just speeded up. Let me check how fast you went at that point. And again, but your car does that for you automatically. Tells you exactly how long it took to get to your destination. Your GPS does the same thing. Your GPS can even tell you how fast you are moving, because the satellites are tracking you. That's kind of scary. It's like it says it can tell how long it's taking you to get to a certain location, and it reads back. And my brother, his speedometer in his truck was not working, so he used his phone. It could tell him how fast he was going. So, and again, when you go for a run, you count steps. Those kinds of things are all done with your phone these days. But we're going to do the old-fashioned way. All right, so motion, remember, is distance, change in distance according to a reference point. Okay, so you can see that the blurry picture of the train seems like it's moving because a person is standing still. They're the reference point. If you're on the train, if it's moving smoothly, you can't tell you're moving very well unless it shakes from side to side. Trains do that all the time. But, you can see that you're moving because you're moving past objects that are standing still. So the rate of change of position of an object in any direction, okay, so speed doesn't care about the direction, right? But velocity does. So the speed is a ratio of distance. So what we mean by ratio, it's something with a division sign in it, right? The ratio, 50 miles. So these guys are going 150 to 200 miles an hour. 150 miles for every miles. And again, I like to look at that slash, that forward slash, as it's a division sign. So this means division. So 150 miles for each hour, or 200 miles for each hour. Anybody racetrack fans here? Anybody like to go on the racetrack? Like to watch races? Anything like that? Dirt car races, Daytona races. Anybody a race fan? Do you really? You have a Bugatti on your game. Wow. They are fun to watch. You got to be careful of those tires if you're out in this as a spectator. Those tires are so sticky that they'll climb walls and they can hurt people. Yeah, it's noisy. So here's some examples of 50 miles per hour, 10 meters per second, right? You can those are the units, meters per second are the units. So our definition for speed is the rate at which an object changes position. And again, if we're looking at rate, so if I'm saying you are, let me go back to a different color here. If you're going 100 meters per second, and the other person's going 50 meters per second, with that information, who's going faster? All right, let's start a poll. Who's faster? Who is faster? Just by looking at that information. Fast. A, 100. Or B, 50. So looking at that information, tell me which one of those, A or B, is faster. So see if that helps you out, because we use those numbers all the time, right? And if you're not sure, put anything in there, right? So 100 meters per second versus 50 meters per second. So what does 100 meters per second say? So it means I'm going so fast that I can cross a football field in 1 second. Second one is I'm so fast that I can be half of a football field in a second. And you guys are right. 12 people said A is faster. So we use that information. People know that. The faster I go, the higher the number, right? All right. So we're going to do some calculations here, and we can use it. We can use those numbers to compare things with. So again, my electric car can go from 0 to 60 in 6 seconds, which is pretty fast. 0 to 60 miles an hour in 6 seconds. I can beat people. Doesn't look like it's a very fast car, but it's because it's electric. The motor just goes screaming, and I can really do that. So but if I want an economy car, gas-powered economy car, from 0 to 60 miles an hour. So like if I'm getting on the highway, I've had cars that take forever. It's like, you want to tell people, I'm sorry. I want to put a sign in the back. I'm sorry, but my car takes a long time to get up to speed. So you might want to move out of the way while I'm coming in. So that's the unfortunate part of this stuff. Okay, so, but with electric cars these days, it's kind of cool. So rate at which an object changes position. So here is 100 meters per second for every second. This slash here, this forward slash, is considered a division sign. Miles divided by seconds, meters divided by seconds, I'm sorry. So distance traveled, we need to know. And then we need to know the time. So speed is distance divided by time. And science uses the meters and the seconds. You can use, if you're not in science, you can use miles and hours, because it makes more sense. If I'm going to California and I'm driving, I don't want to know how long it's going to take me to go in meters per second, right? Or I want to know how many miles I can travel in an hour. Okay, so it's a scalar quantity. Direction does not matter. Okay, so again, so distance can be measured in a variety of different ways. Universally, it's meters. However, there's small distances like centimeters and kilometers and feet and whatever we want to do makes more sense. If I'm measuring how fast a turtle is walking across the road, I'll do meters per second. I won't do miles per hour because they're pretty slow, right? They'll do miles, like maybe half a mile in an hour, or maybe even less than that, depending on the tortoise. Time in seconds, sometimes it's reasonable to use seconds, but then again, if you want to know how long the trip is going to take to grandma's house, we'll use hours. All right, so, and again, we use this thing. We're going to use these pyramids. How many have ever seen these pyramids before? Let me, in the chat, tell me if you've seen these pyramids before. Let me clear this out. Anybody use? I have. Okay, Chloe, Rachel, yeah, okay. They're really convenient to use. Anybody else? So you can say no if you want. Say no, I've never seen them. So that way it'll give me information as far as whether I need to spend more time or less time on this. Because I can tell you, like I said, I know that from the iReady scores that they're probably, there's a lot of you that are struggling in math. And again, we want you to be able to do math, but we don't want you to struggle too hard. But we do have to be able to use these pyramids, okay? So in order to find the speed, the yellow pyramid, okay, this is how I do this. So I use my finger, all right? So I'm going to use my finger. Let me draw a picture with using my finger. In what color? All right, let's do blue. Okay, so if I want to find the speed of something, okay, I cover the S. Okay, now if they're on top of each other, D and T in this pyramid, that means you're going to divide. You got to put distance on top and time on the bottom. And that'll give me my speed. So that's what this says. S, speed, is equal to distance divided by that slash, remember, divided by time. If I want to find distance, I cover this up. Let me use a different color here because they're using blue. I cover this up with my finger. Okay, and now they're side by side. So that means I'm going to use times. So distance is equal to speed times the time. So if I'm going 50 miles, oops, got to use a different color here. If I'm going 50 miles an hour, okay, and I drive 2 hours, I get 100 miles. Makes sense. Every hour I'm driving 50 miles. 2 hours means I'm going to get 100 miles. And then finally, if I want to find the time it takes, and sometimes that comes in really handy, but again, like I said, you're using your GPS, you're using your Google Maps, right? And it does it automatically for you. So if I want to know the time between here and, let's say I'm going on a trip to Daytona Beach, it's cold here, all right? So I take the distance divided by the speed. So distance 1,000 miles, and I'm going 50 miles an hour. And that'll tell me the hours. So cross this off. This is 20 hours. Okay, so that's how that works. Okay, so let's do some problems together. Okay, how to solve. We went over that. All right, so here is a typed response. All right, you're going to use your calculator or your phone. Take your phone out. We'll open it up. All right. Go to the part where it says calculator. Right, it says person hiked 3 miles in an hour and a half. How fast was he traveling or walking? So remember, as I said, okay, you want to take and cover up the speed, okay, And now we're going to take the 3 miles on the top, that's my distance, divided by 1.5 hours. Hour and a half is 1.5, converted it. Okay, so what do you get? I know that I appreciate you guys getting in there. Thanks, Kylie and Grace. So 3, if everybody could do that, divided by 1.5, what do you get in miles per hour? Thanks, DeAndre. Noah, thank you much. Dylan. So 3 divided by 1.5. Okay. 3. Okay, if you multiplied it, you get 4.5. That's not right. Right? And if you 3 divided by, forget to put the 1.5 in there, you get 0.2. All right. Thanks, Adriana. Thanks, Danny. Okay, so most of you guys have gotten 2 as your answer. All right, so that's correct. 2 miles per hour. So every hour you walk 2 miles. Now, let's look at this one. Car travels 55 miles per hour. How far will it go? Remember, we are covering up the distance with our finger, and if they're side by side, we're multiplying. So this is going to be 55 times, that's miles per hour, times 5 hours. And I do this as 5 hours over 1. So my H's cancel out. That will tell me just the miles. 55 times 5. All right, what do you get? Yeah, you guys are getting it. Thanks, Noah, Kylie. All right, so if you don't know or don't understand what we're doing, please put that in the chat for me. Right? If you don't understand how we got the numbers we got, you should get 275 miles. 55, use your calculator, miles. Okay? All right? Anybody having problems with that, let me know. Put I don't know, not sure. All right, so 55 times 5 is 275. Okay. One person said 110. I wonder if my 5s look like 2s, because this is multiplication. Delete. Okay. All right, and the last problem here, let's find the time. So if we find the time, we're going to cover up the time with our finger, right? So that means we're going to take distance divided by speed. So the distance is here. This is the distance, the D. And the speed is whenever time you see miles per hour. So if it's broken down, and a lot of times it'll even be 70 HR, right? Or MH. That means divided by. So we're going to take our distance, which is 210, right? And we're going to divide it by 70. What do you get? And if, like I said, if you don't understand how this is going, just put I don't know, and then that will help me figure out who I can break and do in breakout rooms. Okay? So most of you guys have gotten it. Straightforward. All right, so 70. So a shortcut on this, you can, if you do this, you can get rid of the both zeros here. 21 goes, and divided by 7 is 3 hours. Again, you don't have to worry about these so much in terms of if you're having to travel, because your GPS will do that automatically for you. It tells you how far you have to travel. And again, depends again on what the traffic's like, right? So traffic's like, okay. Somebody put 30 hours in. I think they just had the 0 in the wrong place, right? Okay, so 2 miles per hour, 275 miles, and 3 hours. Okay, so we're done with this right now, but I would like to go do an exit quiz here. Where is my library? All right, 10 questions. Don't I have this done? Publish. Okay. So we're going to do classic. Let's do team mode here. Okay, just for this exit quiz, right? So that way you can do this so that you don't feel uncomfortable if you are wanting to practice these. Let me give you the link here. There you go. Let me pause this for a minute. You have to claim it because you have to be able to put in the assignment, okay? Okay, here we go. All right. Okay, DeAndre. Okay, do you want all right, so DeAndre, so what do you want to do for your you can have this week's assignment 1 done if you want to do that, DeAndre. What do you think? You're there, DeAndre. So W2 assignment 1. It's not bonus, DeAndre. It's just points. Okay, assignment 2. Okay, so here's what you have to do. You have to pretend that you turned it in, and then just write me a note saying this is my bonus. Okay, got to turn it in with 0. Okay, because if I put the grade in without it keeps showing up as 0. All right, thanks so much, DeAndre. All right, thanks for your participation, ladies and gentlemen. So let me go back here. Okay, so these are assignments, people that are missing assignments. I'm going to open up. This is for week 1, assignment 2. It's on vectors. So I'll open up a breakout room and invite you guys in. We'll take the next 15 minutes and do that assignment, okay? And I'll give you credit for